I'm just going to give you a quick overview of satellite data, how it can be used, and the use case that we use it for. Hopefully, you'll find it quite interesting. And yeah, let's jump in. So, my name is Paul Duddy. I'm the managing director at Hyperfine here, and we focus mostly on base metal data for market intelligence. We also do mining exploration as well to find certain minerals, but let's just jump into this just now. So basically, you've got satellites which are basically orbiting the Earth every day, all the time. You've got groups of satellites, thousands of satellites up in space, taking photos essentially, and then they're also taking readings as well for different measurements about different things on the Earth. So you can produce pretty interesting images of the Earth of its actual lumpy shape and not perfectly circular like this. With satellite as well. So the satellite imagery side of it, what you can do is you can basically look into images. You can train machine learning programs on images to detect different things. So here, if you wanted to count all of the trampolines in a certain area, then you could count all the trampolines. If you wanted to count all the red cars, you could do that too. Here you've got cow counting. So cow counting is used to understand how much the sort of agriculture going on in a particular country. So usually a lot of the time it's used by governments and things like that. So you've got there's an agriculture part to it. Car counting is another one. So this one's pretty interesting. So like hotels, if you're a company, you're looking to buy a hotel or you're looking to do under or buy an arena or understand the capacity of different arenas, what people will do is they'll take satellite imagery and count how full the car park is over X amount of time. So basically either every month or every 2 weeks, just to see how many times that car park's been full. And if the car park hasn't been full, then you can say this hotel isn't really that busy or the shopping centre isn't really that busy. And that's the idea behind it. This is a bit more what we do. This is an image of a mine, and all of these little tiny like red things and green things over here actually represent different vehicles. And so we are doing, I guess, essentially cow counting or car counting, whatever you want to say. We are doing truck counting or machine counting on mines, so you can count all of the mines, all of the machines on a mine, all the different types and categories, and you can understand like the types of machines that a mine's got, which include like how much fuel they would burn, so how much fuel this mine might use up every day, and what the carbon emissions of that would be, or what the cost of running these machines might be every day for that mine, and that gives you a bit of an understanding of the operational cost, and then of course the scale of it and how much they can actually produce based on how many machines they've actually got. And that's just basically an example like truck counting. For example, here, we'll skip these ones, and that's type of some of the trucks we can get here. We also get all the vehicles and cars as well that are floating around. With the mining industry as well, what we can do is we can detect all of the movements on the mine. So on here, these colours represent different movements during different times. So for example, like the purple area might represent the first quarter, and the green area might represent the second quarter, and the blue area the third quarter, and so on. So you can actually detect the movements produced on a mine. So that's these big trucks that are moving things back and forth and changing the shape of the landscape, and then you can detect that change using INSAR basically to detect the ground movement. So it's very cool that you can actually see the shape of the ground changing over time. And you can see here, so like the roads are always white because basically there's always trucks driving on them, so there's always some movement on the roads, and then you can just sort of zoom in and see where these patterns are. So like over this area there's not too much activity, whereas you can see most of the activities actually happening here, and then there's some happening down here. So you can produce these pretty cool images as well from this data, and of course this can be expressed in numbers as well, so you can sort of calculate it, express it as a number, and then calculate it, add it into statistical analysis. You can do digital elevation models. So these are quite useful for understanding smaller mines that might be a bit more difficult to detect what they are actually doing. For example, it might be like 5 guys on a mine just essentially digging year in, year out, but it doesn't produce the same large scale movements that these bigger mines produce. Land surface temperatures, so that's basically the surface temperature change. So for example, if you had like a mine and then there's some trees next to it and you wanted to expand and you cut down the trees, that would result in a change in the land surface temperature, so you could detect that. You could find that sort of change detection basically by the trees being chopped down and the surface temperature changing. You can also do that with like NDVIs as well. This is just like some infrastructure work that we've done before, so you can monitor things going on with construction works. Not really done that often, but basically this one's HS2 in the UK, where they're just building this super huge train station, and you can see as it's expanding further and further in those images. This is the same train station, and up here that train station actually sits in this area, so everything that's red is actually basically dead vegetation. There's no vegetation there, so you'd expect to see red, and everywhere it's green is good vegetation. Everything that's yellow is sort of in between. So the vegetation index is quite good for helping you to understand the general health of the vegetation around certain areas, which can include mines and construction sites and areas of like heavy industry, for example, which you don't want. You don't want that area to be, everything around it to be basically dying, essentially, because it could mean there's a leak or there's some poison coming out somewhere. This is another one. This is a mine here, and then this mine is in sort of very hot country. It's in Africa somewhere. And this one is, you've got your a vegetation index here, so you can see this is where all the sort of green is and where all the veg is. There's actually houses over here, so there's some vegetation over here. So you wouldn't expect too much vegetation to be around this mine because it's basically in the desert. But there is still some tree planting monitoring. So this is quite an interesting one. Basically, you can use medium to high, I guess, resolution satellite data to monitor forests. You can watch things, so you can see like tree thinning quite easily and quite quickly, to see if, for example, you're the council and you're wanting to monitor if contractors actually done the job on a really large scale. Then you can quite easily do that with satellite data, and you can see that the trees have been thinned out. And then you can also do things like that on the NDVI, because you would see there'd be a change in the density of the green area. So that's another way of actually understanding forest management, basically. We'll skip that one for the now. This is another pretty interesting one. This is on the HS2 site, the train site, and we're just doing scenario planning for floods. So if there was a flood on HS2 during the construction, you can see it would actually, and a pretty extreme flood as well, not a normal flood or a normal flood, but a very extreme flood. You would see that the construction site would start to flood over here. You'll see it flooding in these different areas, and we actually overlaid this with different types of data to kind of get this analysis done. Contour maps, so you can produce contour maps with satellite data as well. Pretty good for large scale areas. You might be better with drones for smaller scale areas, or high resolution data for all that from satellites. Basically with satellite data you can get high resolution and low resolution. Generally speaking, you're paying for the high one, and the one that's low resolution is free, which you can get from the European Space Agency and NASA, for example. Land surface temperature, just another type of view, but also gives you the scale of some of the imagery from satellites. So you've got like quite a few countries all just sitting in this one image, this one raw image. Road network analysis, ferrous metal content. So a bit like a giant metal detector from space. Not exactly the same, but what you've got here is basically you're detecting iron content in this mine over a number of years. So basically taking the average over 12 months and then just producing this image to show what it was in 2016 and then 2020. And you see there's quite big changes going on there. And you can do that with different types of metals as well, different types of minerals as well. Just some more iron content. And here we've actually got a bit of lithium showing in the water. So there's another example of doing lithium monitoring or mineral monitoring. Just another interesting raw image. It's basically almost the whole country here in this one square. And here again, basically we're just picking up where we think there might be lithium sites. Here we've got some, this is where we are seeing some limestone So part of this image is showing, basically we get some limestone shown here and some here, these dark blue areas. So it's just another area of what you can use satellite data to detect certain things and interesting things from space, basically. And so these are all like imagery, like data points, basically. And what we've got here, like this is an image that you would buy from one of the providers, satellite providers, from one of the companies that built and sent a satellite up into space. So, for example, here we've got a picture of a mine. It's not the whole mine, but you can see we're going to start zooming in on this area. So, if you come down again, you zoom in, and you can see we're in here, and you can start to see those little trucks and cars and stuff here. We zoom in again, and then you can see that you've got some machines here. They're drilling holes. And basically, this is quite useful for understanding the progress of a mine from month to month, where they're basically drilling X number of holes. They're going to blow a hole in the ground, basically, and start digging out the minerals and excavating it out. So that's basically what this is. And some more satellite imagery as well. Just to give you an idea of some of the costs for it. So what we were seeing just previously was basically this one. And then we've got pricing over here, and then it can be used for car count, for example. And then the same area, which actually it's this area here. You've got this lower resolution imagery, but you can still make out that there's houses there and there's some construction work going on there, and you can see the cost is much cheaper here. If you can use Bing Maps or Google Maps to your advantage, then you can actually see the satellite imagery as well. It was actually very high with them, but you can also sometimes get the date on it as well, so that you can view it on the date that you want to see that imagery. And then that's it. So that was just a super quick overview of some of the stuff that you can do with satellites. Granted, it was focused mostly on the mining industry. That's kind of where most of our experience is. But if that's useful to you, then good. If you found it entertaining, good. And I'll be on another video soon. Cheers.